Thank you very much, Kurt. Everyone. I would like to, first of all, introduce you to others that are involved in this webinar. We have Kent, Solution Architect from Red Hat, who will bring an introduction to Red Hat and the portfolio of products that we're using on this webinar. We also have Jose on the call. He kind of put together the demonstration that I'm going to be presenting towards the end of the webinar. And I'm Ian Purdy, Managing Director of Crossvale Europe. The content of the presentation today is going to be around 15 minutes of setting the scene and making sure that we're all on the same page as regards terminology and what we're trying to do here. And then the latter half will be a demonstration of the DevOps principles in practice. Let me just very quick introduction to Crossvale. Of global nation that operates in the North American market, in Europe, and in the Middle East. We have about 100 specialist employees, and we concentrate mostly on helping companies to move forward on their digitalization journey. We have expertise in integration, business process management, and IoT. We have a number of partners. We're very proud of our partnership plaque that's in the headquarters at Dallas for Red Hat, and I would have to say, and I wasn't paid to say this, that we find Red Hat a partner that's second to none. Also, just to share with you some of the names that we have worked with globally. And I would like to hand over to you if you would like to do an introduction to Red Hat and the portfolio.
And so Red Hat is, we do provide commercial IT products based on open source software. Actually, from this slide, we're actually at about 10,500 employees now. So Red Hat is a growing organization, and fortunately, more than 90% use Red Hat products and solutions. Next, please. So talk about containers as part of the platform. So we talk digital transformation as the headlining piece of it. So as part of digital transformation, containers can play a vital role in that transformation process. As you can see here, Red Hat does provide solutions for various areas within your organization, depending on wherever you are as it relates to your application, infrastructure, and processes. So at it today, containers will play a vital role in the demonstration that Crossvale is providing, and can see different components where it plays vital parts and going from there, where it can fall within your organization today, whether that be from infrastructure, moving to a hybrid infrastructure, or moving into end-tier microservices type architecture, and lastly moving towards DevOps, as we'll see a little bit more of that in the demonstration. Please. Next, please.
Yeah, refreshing that.
Containers as a transformation mechanism. Red Hat OpenShift is Red Hat's container platform, a platform that's being used today as the core of today's demonstration. With that, a lot of components from Red Hat are provided as images, container images. So some we'll see today are, for instance, AMQ, JBoss Views, validation and messaging platforms, as well as other collection components such as Node.js, as well as Jenkins being provided an image from Red Hat. There are also other images provided by other ISVs, but OpenShift also works with container images that are available on Docker Hub as well.
Okay, thank you. With customers from a variety of verticals and industries, we've seen questions come up again and again, and the two that seem to surface most often are, how can I prepare for the unexpected? That unexpected might be competitors entering into my market that weren't there before. It may be legislation being imposed upon me. It may be disruptive technologies, or it may just be that my services have become exceedingly popular and there's an explosion in the use of them. The second is, how can I take advantage of new market opportunities as they arise? And I think the answer to both of these questions really lies in being able to repurpose systems as opportunities and threats arise. So we're not using a hard-baked solution that is very difficult to twist and turn as need it to, but something that can very quickly be turned to our advantage. And I believe the secret to this is a number of emerging technologies. Now, some of these you probably already be adopted and be using, but I think we really only get the full advantage when we bring them all together. And that's what I'm going to try and cover on this webinar, is how we bring all these things together to be really competitive. This one is agile methodologies. We have first makes a significant difference in the time to market for changing our systems. But not only that, it helps us more readily meet the expectations of our customers. So the lines of businesses find that the solutions that we are providing more clearly meet their requirements because they're involved in the process of developing those solutions. But in my experience, having agile methodology significantly reduced, the advantage of it significantly reduced if we don't have DevOps. Because what we find then is that although our development processes are very slick and very efficient, they to a throttle that's at the deployment stage, which can cause us a problem in to respond to the needs of the business. DevOps does is it brings together two parts of the organization that are typically have very different views of things. The operations organization, they view change as a very bad thing usually. Where developers, it's their reason to be, it's their raison d'etre. And what we're trying to do with DevOps is to bring those two different together so they have a solution that suits the requirements of both. And that's what I'm going to try and cover today, to explain how we do that, how we meet the requirements of those two parts of the organization. What I'd like to cover today is microservices. And really all three of these things must go together. It's not really practical to use agile methodology or DevOps if we don't move towards a microservices type architecture. If we move from those monolithic architectures that we've had in the past to have services which do one thing and one thing only and do that really well. And we've got here in the CXP platform that we're going to demonstrate is that we are putting together these microservices in such a way that we produce a solution for one particular scenario, but it's very easy to mold that to a different scenario by just using the same microservices orchestrated in a different way. The other thing about microservices is it means that when you're making changes, just changing a small part of your architecture, you're not changing the whole thing, and that suits the DevOps and agile methodology very well. The advantages of microservices is as well that we can open up these services to the rest of the enterprise, and the opportunity to use these services, these microservices, in innovative ways. But what we find is that really clever organizations not only open this up to their own enterprise, but they also open it up to external organizations. In order to do that successfully, we need to provide the APIs, we need to provide sandboxes where they can try them out, we need to provide example code snippets in popular languages to help to make these APIs more accessible. But once we do that, oftentimes we can monetize those APIs. The side is, now that we have external people using our microservices, we can find that the ability to predict the use of those services becomes very much more difficult. And to meet that, with some more of the emerging technologies that I'm going to speak about later, we can have scaling, automatic scaling of our microservices, and we'll see how OpenShift is able to do that. Another part of context of what we're talking about today is that in the past, we found most of these services would have been consumed through laptops, desktop computers, computers. And what we know now is that services are being consumed from a plethora of different devices, oftentimes mobile devices, even wearables now, like Alexa, Google Home, and we're needing to make sure that our solutions can support all these different channels. But also, not only are these devices ways of exposing services to customers, but those devices often are contributing to information about our customers. So able to gather information from these devices. This is commonly referred to as the Internet of Things. And what it is that as we start to not only expose our services to these multiple new devices, gather information from these devices, events from these devices, we discover that the volume of data that we have to deal with explodes. That's where the concept of big data comes into play. Now, data is very easy to collect. It's very easy to collect all this information. It's making sense of that data that's really important. And it's one of the things I would like to show you today is how we can use OpenShift, other components of Red Hat, such as the service bus views, how we can use those with business rules to extract intelligence from that data and use it in order to enhance our customer experience. I think many people on this call will already have some familiarity with DevOps, but I expect most of us have more experience with traditional IT and problems that it poses. I'm going to go through this complete list, but I'd like to draw attention to a couple of specific points in here. The first is what we mentioned already, that traditional IT, we tend to have large projects. I remember early on in my career, we had a discount scheme being introduced by a large telco. The plan would have been 18 months to introduce it. And because it was such a mammoth effort, we spent a huge amount of time at the beginning of the project making sure we'd got everything right. And we just planned to have one project, one release, because it was expensive to do all the testing and all the deployment activities and making sure everything was going to work. Releases were high-risk events. Now with DevOps, we're getting to the point where a release is actually a non-event. It's a bit like breathing. We do it so often that we have to think about it. And that's where we want to try and get to with DevOps, where we just do things without having to be a huge conscious effort, but with the surety, with the certainty that it has been properly quality gated, so that there's not going to be problems when it does go. So instead of not failing at all and a huge amount of effort into that, we recognize that sometimes things do go wrong. And instead of making sure we don't, we instead make sure that we can cope with those failures, that we can address them early on in the process so that they don't actually reach real customers. Whenever I worked in the industry 20 years ago, people define done as I've done my bit. And what we're seeing now with a DevOps culture is that people start to work as one big team, and everybody recognizes that the job is not done until it's deployed and working. What I'd like to do is talk through the digitalization journey that most of us have at least started on, and talk about where we think it is going. So, at the beginning, most of our customers would have interacted with us in our branches. I'm talking mostly about the banking industry. And it would have been at a time that suited us. What we then moved to was providing an online experience for customers, but more recently, our customers expect to deal with us on their own terms through social media channels, and so we have to listen to those channels. We use them for advertising so that we can reach our customers, but we're also finding that if we really want to understand our customers' pet likes and dislikes, we have got to engage with these channels and gather data from them. That produces a lot of data, and it's a real challenge to make sense of it. But when we reduce the 80 billion devices that are expected to come along with the Internet of Things, that produces a lot more data. And within Crossvale, the way that we propose that should address this is have a component we call the ingester component. And that component is responsible for taking all those raw events and transferring them into our big data repository. But it doesn't just transfer them as raw events. It's guarding ones that we believe are not going to be relevant for the decisions we're going to try and make. It also will shape that data and may do aggregation as well to minimize the amount of network traffic we have. So this ingester would typically be at the edge of the network, making sense of the data according to the compute power that's available there. Aggregator. And this is one of the key elements of the architecture. It's always running, always analyzing in real time the data that we have in our big data repository. And it's generating events then. Generating events that go into our enterprise service bus. And that enterprise service bus is made of a number of microservices, or it's interfacing to a number of microservices. Some of these are common components that we will use in all our applications. Some of them are business rules, for example, that we would use for the aggregator to work out what it should do. Some of them will be interfacing to enterprise applications such as CRM, ERP, e-commerce, and so on. And that ESB can push that information out to our customer vendors or indeed out to our customers. And oftentimes it's directly to the customer pushing out to their mobile devices. Or indeed the ingester can push information back to the customer in even more real time as it comes into the ingester. I liken this to being like a reflex reaction. So the ingester is like a reflex reaction, whereas the information coming back from the ESB is more of a cognitive, like coming from the brain. I want to step through quite quickly continuous integration and continuous development just to make sure we understand all the terms involved, and then we'll very quickly after that move into the demonstration. So this is a journey. We probably all by now have code repositories. It's considered to be a very stat hygiene factor in the project, but what's important is to have a good strategy so that we can control not only what's on the logs, but also what we have in the various dev and test staging environments. We recommend that we have pull requests and code reviews. This keeps control then of what is pushed into the branches that are going to actually end up as releases. The automated push, and you'll see this theme again and again in DevOps. Instead of things manual, we're constantly pushing for things to be automated. And because things are automated, it then gives the DevOps team more time to spend on automating things, so it becomes sort of an ameliorating cycle. And one of the key areas for this is automation on the quality checks. Can we automate the quality gates themselves? Test is part of the daily development activities, so whether it's test-driven development or behavior-driven development, we sat as part of the DevOps team to make sure that they're developing tests at the same time as they're developing the solutions. I'm going to quickly through then to continuous development. We need release artifacts stored in the repository, something like Nexus. We want button deployment to all our environments. We need smoke tests. Requirements are defined in Gherkin. I'm going to do these slides, so I'm not going to step through all of these in the interest of time, but all of these points, I believe, are important in order to reach the nirvana that we're aiming for, where we can be really competitive in our deployment. We'll quickly step through the OpenShift architecture, and I will try and do this very quickly. We can deploy this OpenShift architecture on a variety of infrastructure, so whether it's bare metal or virtual environments, and in fact it can even be a hybrid of private or public clouds. We have types of nodes. We've got master nodes and worker nodes. On the master node, it looks after API authentication. It's going to do things like keeping track of what the current state of the cluster is and what the desired state is. It's a scheduler that works out where to put work on the work nodes, and it does the health and scaling. So it will look after monitoring the worker nodes to work out whether or not something needs to be scaled up. This layer that manages the interaction between these various nodes. We have a routing layer which manages the ingress and egress of traffic to the cluster. We have persistent storage because although we are scaling up and down the nodes, oftentimes those nodes have to have persistent storage because they have stateful services rather than being all ethereal. And then we have a registry, which is where we store the Docker images, and we'll see that later. The interaction with the developer is through the master. There's APIs there for doing the various activities that a developer would do. I just want to highlight that although our demo this afternoon is on a single node on AWS, typically would be recommending the high availability architecture where you would have several masters, several intranodes, and several workers. And we may do a further webinar on this at a later stage if there's sufficient interest. Actually, I get quite excited about this because whenever you get this cluster working, you can actually go in PS-EF, kill -9 on process, knock down everything until you've only got one worker left, and you can still see your business processes working without any glitches. It's really pretty exciting to see. Okay, I'll move over towards the demo then. And before we start, I would just like to step you through what it is we're going to show you so that you can recognize the various parts. So we're going to have a CXP platform, which is your customer experience platform, that is made up, it's basically just an Angular front end, but it is exposing the microservices that are lying behind it. And I'll try and explain to you what microservices we're using as we go. So those microservices, for example, will be accessing the big data. And that big data could be coming from a number of sources. One such would be the legacy databases of your organization. And what I'm trying to do here is to relieve those legacy systems of some of the transactions that they would previously have had done. And it also gives you opportunities to do things that you wouldn't be able to do in the legacy databases, often more quickly and less expensively. Also, the big data repository will often be pulling things from third-party APIs, and we'll show you an example of that later as well. And we've got Gesture that we spoke about earlier, and it's going to be pulling in feeds from Twitter. Just as an example, we have other components for pulling in from other social media channels or from other third-party services, but this is just the example we're going to use today. And have our aggregator working on that big data, pulling out information, running business rules against it, and then feeding through the ESB back through microservices to the CXP platform. What we're going to show today is how we use all the information from these various sources of information to be able to make offers, for example, to customers, intelligent offers. And I'll show you that now. So let's just step across into the here. So the screen. And I said before, this is a very cut-down version of our main product. And I should also say that the data is all randomly generated, so if it doesn't look very sensible, that's intended. If we log in here, okay, we can search for a customer and can do partial searches. And we put this front end on legacy systems, so things that wouldn't typically be supported on your legacy system because of the expensiveness in terms of compute power, we can now do because we have got a cache in front of it. We can do sort those columns, we can then click through to that, and now the dashboard. As I said before, this is just an example dashboard, a number of components here, and the key thing here is that this is actually surfacing the microservices we spoke about earlier. So I have a microservice, for example, behind this customer profile tab that's pulling information from our big data repository that originated from our legacy systems. So we know here, for example, that this customer is a VIP Tier 2 customer. We also have another tab which is showing us information about the credit and debit product of this customer. And we can see an aggregated view of that here. So if I now then click on the debit view, it changes this to debits, and you'll see here we've got our external savings bank information here as well. And what we're able to do now is get not just a 360-degree view of a customer, which is quite common in the industry, where you're seeing a view of a customer as far as your systems tell you. We call 361-degree view of the customer, where you're actually seeing more than what your own systems will tell you. And the services for the Twitter, it's feeding through as well. And what we're to do then is, in our business rules, we're able to pull all this information together. The fact it's a VIP customer, the fact that they've got a huge amount of credit, not with us, but with somebody else, of funds with somebody else. We can also see that they've almost run out of their line of credit, and they've just won a project in Paris, so they're likely to need a huge injection of cash to get that going. So we can pull all that information together from the various microservices, present them as components on this dashboard, but also make intelligent decisions on that information and start to present offers to the customer that would actually take them quite a while to work out themselves. But these are microservice, the suggested offers microservice is actually making sense of all this data and pushing a very simple view to them of what they be present for the customer. This is an example in one industry, but the same concepts apply to lots of different industries. What I'd like to do now is to step back into the slides and show you the next step, which is where we put change. UI and the microservices, they're running in pods on OpenShift. And a change to that cluster, we can just push a change into GitHub, which is our code repository. That then can automatically trigger a Jenkins pipeline. It has plugins for Jenkins, but we can also use other CI tools with it. There's an interface we can use there. But the point is that pipeline can be quite simple, which we're demonstrating today, or it can be very complex. So it can do all sorts of code analysis, it can do kickoff testing, and it can roll back deployments if you run into any quality gate issues as you're going through. So we'll demonstrate that. The one that we're going to demonstrate today kicks off an OpenShift build. So it actually builds the code directly from GitHub. So it does a pull of that code into the pod. And once it's built that, it registers that new image in the Docker registry in the OpenShift cluster. And then it kicks off an automatic deployment of that new artifact into the UI. So that's going to demonstrate now, that full end-to-end push. So what you have to realize here is that developers, although all the checks and balances are placed in terms of testing and code reviews and so on, they change and it ripples all the way through to whichever environment we have here. In this particular case, it's a development environment, but you could have it then go staging into production. So let me jump back again to the demo. And to make a change, fortunately I remember the line number, 129. I hope that I've already got in my paper the code that I've put in to save a little bit of time. Go down, we're just going to change the background color. Oh, no, that I'm from the UK rather than from the US. As soon as I push this, it's going to trigger the Jenkins pipeline. So I'm going here and look at builds. And here you see the last successful one, and you can see that 5 seconds ago we kicked a new build. Okay, now that new build is actually run in the OpenShift cluster, and we can see here the Jenkins output running through the various stages of that pipeline. The pipeline is just the workflow, if you like, of the things that you have to do to take this code from the repository to your cluster. So let's jump back to the web console. I want to just share with you what a build fig looks like. So here we're changing the front end. You can see the history of the builds over the last, how many there are, 35 or 37. We get the latest one running here. We can either edit in YAML or we can have a form-based editor. Advanced options. So here you can see the Git repository we're pulling the code from. You can say which branch this particular environment should be pulling from. We can create secrets here so that even if it's a private repository, we can pull it. And we've all sorts of other things here we probably don't have time to go into just now, including environment variables that we can set up. We can set up build secrets and run policies and so on. Let's cancel out of that. Deployments. So if we go to deployments view, we can see the front end here. We have a number of deployments. The last one was 38 minutes ago. And we look at the here we have type. So OpenShift supports a number of strategies. I find it really pretty cool. It means that you can decide whether you want a recreate strategy, which means it takes down all your pods and recreates them again, or you can have a rolling strategy, which is what we're going to do here, which means that it actually starts up some of your new pods before it starts taking down the old pods, and say what percentage of unavailable you're going to allow and what surge number you're going to have. And that will then allow business to continue even while you're doing deployment. Let's go and have a look at that. Look at the overview. Now 4 front-end pods running, and they're currently on build 61. If we scroll down, we can see the injector pod, which is the one that's bringing in the tweets from Twitter and putting them into the big data repository. We can manually scale that up or down. So if we scale it up to 3, for example, in seconds, we have a complete new container layer running, capturing those extra tweets. And we can set up so it will auto-scale. I'm not going to demonstrate that today, but we can. Or we can scale down again. Our build still firing away here. We can see the build on the front end is running. Minutes ago it started. Experience, this takes about 3.5 minutes, so hopefully within a few seconds we should see this deploy. There you go, look at that. Perfect. So what you can see here, these are your old pods, these are your new pods, so it has already scaled up 1, 2, and you can see that at any point in time we have 4 pods. So we have any search during our deployment. Pretty cool, eh? So what we're going to do now is we're going to go to our front-end application again. I'm going to just close it there. We can go to it from here, or we can go from whatever website or we can have. If you're to make the background yellow, and oh, that's horrible. This is where the ability to roll back is pretty cool, because yellow does not work. So let's close that, and we go back into here and just say, okay, let's look at our deployments. This deployment on the front end was 2, so we'll go back to 61. So if we click on 61, and then we just select some optional values here, and then click rollback. So now if we go to our overview, started to roll back. And again, it's using the rolling strategy that we selected, but it could be just as easily a recreate, or in fact, you can have custom deployment strategies as well. And then this is the first stage, and we're back to our grey background. Okay. Let's back to our slides once more. We're nearly there. And I want to show you one last thing, where when we have our tweets coming in through our ingester, our big data repository, the aggregator's analyzing those, and it's deciding, oh, here's an interesting tweet or series of tweets, so I'm going to create a new customer for this. So create customer event from the aggregator into the ESB, and SB sends a notify customer support from ESB into BPM. And we can start off either an automated or partially automated manual process for creating a new customer. So we're going to go back into here and have a look at that in the OpenShift cluster. So if I go to Overview, and the thing we're going to look at is the injector, which we looked at before. So if I have a look at the injector pod, and I go into terminal mode on this, and we start investigating this if we've got any problems with it. But for today, we're just going to look at the logs, and here you can see the tweets coming in at a reasonable rate of knots. What is step back out, and we'll look at a couple of other services. So the first one I'm going to look at here is CML. This is the service that is going to pull from the big data repository and put the events into a queue. Kent at the beginning mentioned about the AMQ. So we have a console, and because it's all integrated with OpenShift, we can here view our root diagram of that service. And here you see the numbers of tweets coming in time and pushed as it happens to these various queues. And now what we do is go back to our overview. And look at which is the station which is pushing those events then out to BPM. We can open the console, see our definition, see our definition, simple one, but it'll work just as well if it's several pages of process. And then what we can do is go back, look at our logs, and we can eventing message notifying customer support. So in real time, it's putting out those create customer events. And one last time, go back to my menu. So what we've demonstrated is that Crossvale can make DevOps a reality. Work to on your particular current needs, because this is a generic approach we're showing you here. But if you are interested in moving further along this DevOps journey, then please feel free to give us a shout, and we'll be very glad to work with you to help you understand how to move forward. Move to Q&A now.
Yeah, remind everyone that the Q&A panel is located on your screen in one of a couple of places. The tab up at the top, if you put your mouse on it, it should drop down. And in that panel, you can place questions. If you're looking in the split screen view, you'll find the Q&A panel over on the right-hand side. But in either case, feel free to enter questions you may have, enter them into the panel there, and click on the send button, and we'll be able to pick those up. I'll let you go through a couple of those questions that we have already.
Yep. So what we have here is asking about whether CXP is a COTS package, or whether it's a framework, or what it is. So I think to answer that, I would refer back to what we were saying earlier, which is that though we have instances of this in a number of customers, it's really about the microservices and how we pull them together. So I wouldn't regard it either as a COTS package in the normal sense of the word, or indeed as a framework. It is actually a product, but you can bring it together to suit the requirements of an individual customer. Any other questions? Oh, there's another one. Okay, so you're asking what are the differences between using this, for example, and using plain Kubernetes, using OpenShift and plain Kubernetes. There are a number of things that we get with OpenShift compared to Kubernetes. One of the things we get is multi-tenancy. So, for example, we set up OpenShift where you can have a number of different organizations or even departments of the same organization working in isolation to each other. So multi-tenancy is something that you wouldn't get in Kubernetes. A number of other aspects around security, in relation to scaling, automatic scaling. We have things like the automation of the orchestration of pods. Kent, would you come in here? Are there any other things that you would like to add to that?
A lot of it has to do with some of the pieces. For instance, in image history, having that portal that Ian was demonstrating, the metrics and logging, the aggregated logging, we didn't get a chance to see that, but also metrics as it relates. And the networking infrastructure, Kubernetes doesn't provide that aspect from a Red Hat perspective. OpenShift provides a preset OpenShift software-defined network, or you can plug in your own if you have one as well.
Okay, right. One more question coming through there. A question on the Fuse camel route. Would you deploy them as microservice apps too? I mean, would you have multiple Fuse projects running on multiple containers, or would you put all your camel routes in the same app and make it a centralized bus? Interesting question. Would you like to take that one, Jose, or would you like me to take it? Okay. So I think it does depend on the specifics of what you're trying to do here. One of the advantages of microservices is that you split things out so they just do one thing, which means that whenever you're making changes, the potential risk of affecting something else is minimized. It also reduces the amount of time it takes to do the deployment. Some advantages sometimes to have them all centralized, but I think the default position would be you would break that up as much as you can. The containers are very efficient in unlike VMs where you have a very heavyweight component. With containers, it's very the overhead of each container is quite low, so there's no real strong reason for not breaking up your services into multiple services. Kent, did you add anything to that?
Sure. Piece is that this is being deployed on the OpenShift platform, so OpenShift manages a lot of the availability of the services itself, as well as the segregation of the services. Normally, typically, if you look at on-prem or just a standalone Fuse deployment, you manage it within multiple Fuse containers, and you bundle services as you deem necessary as part of a bundle or groups of services. So with OpenShift, as Ian had mentioned, from moving it from a microservice point of view is being able to isolate them so that you can scale them accordingly, as well as help you with various microservices such as circuit breaker or other facets, in a sense of being able to handle error handling when issues do occur with various services.
Thanks. We have another. We're getting a lot of questions here. I'm afraid we're not going to be able to answer them all, but feel free to call us after the call. I'm going to take one more. So you're saying, what was the panel during the demo that showed camel info and some metrics? It said connected to Spring Boot. So as Kent said at the very start, one of the advantages of OpenShift is that it is very closely integrated, very well integrated with a number of Red Hat products, and one of those is the Fuse product. So that from within OpenShift, you can actually open up a view of your camel routes. So what was mentioned about Spring Boot, that's just the way we have deployed them. But you're really using OpenShift functionality to view those camel routes. Again, correct. Kent, I'm very happy for you to add to that, please.
Yeah, as part of OpenShift, the Fuse integration services, as it's called, it can be deployed in various manners, such as a pure Java container or then a Carafe container. So you do have options of deploying Fuse itself for the underlying runtime. However, from a management perspective, it does go back to OpenShift.
And I'm just going to mention one more. Someone was asking, are there any future webinars on Fuse and OpenShift iPaaS? So I'm fully expecting we will do some follow-up webinars. and I'm very happy to do one on Fuse and OpenShift iPass, but I'm sure there's probably some others that people would like to see. So can I suggest that you use the email that we showed earlier? I'll try and bring it up again to send in your suggestions, and we'll make sure that we get into them if feasible. And that's sufficient for today. What do you think?
All right, sounds good. Well, ladies and gentlemen, this does conclude your session for today. On behalf of all your panelists, I'd like to once again thank everyone for joining and hope you found it informative. At this time, you may now disconnect the rest of your day.